Welcome to Simultaneous Equations Level 6. Pause the video now, try the 3 problems on the screen, and I'll go through them with you shortly. You'll find more practice at this level, plus links to the higher levels, as well as other topics, at the end of this video and on the channel homepage. In problem 1, we're solving 2x minus y equals 3 and x squared equals 41 minus y squared. Now, since we have a linear and a non-linear equation here, we need to use substitution to solve these. And to do this, we need to have the linear equation with either x or y as a subject. So looking at the linear equation, 2x minus y is equal to 3. We're going to try and make y the subject. And we can start doing that by first adding y to the left and adding y to the right. So on the left, the minus y and the plus y cancel out to leave us with 2x. And on the right, 3 plus y just becomes 3 plus y, or y plus 3. To remove the plus 3 from the right, we can now subtract 3 from both sides. And on the left, we have 2x minus 3, and on the right, we just have y. So we've made y the subject. And this is useful because we can now take 2x minus 3, which we know is equal to y, and substitute it as y into our nonlinear equation. So that second equation, x squared is equal to 41 minus y squared, now becomes x squared is equal to 41 minus, and then in brackets, 2x minus 3 squared, because we've replaced y with 2x minus 3. To continue, we now want to expand the brackets, so we can rewrite this equation as x squared is equal to 41 minus, and then 2x minus 3 multiplied by itself. Now, it's really important here to understand that the minus in front of those two brackets is like having a minus 1 there. So we can now expand the brackets by writing the equation as x squared is equal to 41 minus 1 times, and so we need to make sure we have another bracket here, 2x times 2x, which is 4x squared, 2x multiplied by minus 3, which is minus 6x, minus 3 multiplied by 2x, which is minus 6x again, and minus 3 multiplied by minus 3, which is plus 9. We can now expand the final bracket, so we have x squared is equal to 41, and the minus 1 outside the bracket is going to multiply everything in the bracket by minus 1, and all this does is it changes the sign on each of the terms. So the 4x squared becomes a minus 4x squared, the minus 6x's both become plus 6x's, and the plus 9 becomes a minus 9. We can now simplify the right hand side by collecting the like terms together. So we have minus 4x squared. We can collect together a plus 6x and a plus 6x to give us plus 12x. And we also have 41 minus 9, which gives us plus 32. Since we're solving a quadratic here, we'd like it to be equal to 0. And so we can remove the x squared from the left by subtracting x squared from that side and doing the same on the right. And on the left, the x squared and the minus x squared becomes 0. And on the right, minus 4x squared minus x squared gives us minus 5x squared. So we have minus 5x squared plus 12x plus 32. Now, in equations like these, we'd like our x squared term to be positive. It often really helps. So to achieve this, we're going to multiply the whole of this equation by minus 1. And so this gives us 0 times minus 1 is 0. Minus 5 times minus 1 is just 5, so we have 5x squared. 12x times minus 1 is minus 12x. And 32 times minus 1 is minus 32. Now, since we have a number in front of the x squared that's not 1, and we can't divide through by 5, what this means is that we could try and factorise, but the easiest method is probably going to be to use a quadratic formula. And before we can use this formula, we need to establish the values of a, b and c. So a is always the number in front of the x squared, so in this case that's 5. B is the number in front of the x, which is minus 12, and c is the constant at the end, that's minus 32. So we can now substitute these into the formula, and this gives x is equal to, and on the numerator we have minus b, and since b is minus 12, this is minus 12, or just 12, plus minus the square root of b squared, and since b is negative, we need to make sure that goes in brackets with the squared on the outside, minus 4 times a, which is 5, times c, which is minus 32, all over 2 times a, which is 2 times 5. And if we put this into our calculator first with a plus on the numerator, we get x is equal to 4. If we repeat this, but with a minus on the numerator this time, we get our second solution, which is x is equal to minus 8/5, or minus 1.6. So these form the first parts of our solution. To continue, we now need to find a corresponding y value for each of these x values. And to do this, we're going to use the equation that we rearranged earlier, because this has y as a subject. So we're going to use y is equal to 2x minus 3. And when x is equal to 4, this equation becomes y is equal to 2 times 4 minus 3. 2 times 4 is 8, minus 3 is 5. So y equals 5 makes a pair with x equals 4. We can now do the same thing with x is equal to minus 8/5 and substitute it into this equation. So this becomes y equals 2 times minus 8/5 minus 3. And this gives us y is equal to minus 31 over 5, which makes a pair with x equals minus 8/5. So our final solution to problem 1 is x is equal to 4, y is equal to 5, that's our first pair, and x is equal to minus 8/5, y is equal to minus 31 over 5. In problem 2, we're solving 3x squared plus y squared minus xy equals 5 and 2x minus y equals 3. Now we have a non-linear and a linear equation here, so we need to solve these by substitution. And to start, we need to rearrange the linear equation so that either x or y is the subject. So our linear equation, 2x minus y equals 3, can easily be rearranged to make y the subject. And we can do this in 2 steps. First, we can add y to the left and do the same to the right. This is going to remove the minus y from the left and make a positive y on the right hand side. So this gives us 2x is equal to 3 plus y. And now we can remove the 3 from the right, and we can do this by subtracting 3 on both sides. So we have 2x minus 3 is equal to y. So y is now the subject. And this is important because we can now take 2x minus 3, which we know is equal to y, and substitute it into the nonlinear equation in place of y. So the nonlinear equation, 3x squared plus y squared minus xy is equal to 5 now becomes 3x squared plus, and we're going to replace this y squared with 2x minus 3 squared minus xy, and again we're going to replace the y with 2x minus 3 is equal to 5. And we now have an equation that's just in terms of x, so we should be able to expand, simplify, and then solve. So to start, our squared bracket can be written as 2x minus 3 multiplied by itself. And the second bracket we can expand. So we have minus x multiplied by 2x, which is minus 2x squared. And then we have minus x multiplied by minus 3, which is plus 3x. And that's equal to 5. We're now going to expand the double bracket. So we have 3x squared plus, and we have 2x times 2x, which is 4x squared. 2x times minus 3, which is minus 6x, minus 3 times 2x, which is again minus 6x, and minus 3 times minus 3, which is plus 9. And we still have a minus 2x squared, a plus 3x, and that's equal to 5. Now on the left hand side, we can simplify by collecting together the like terms. So starting with the x squareds, we have 3x squared plus 4x squared, which is 7x squared, minus 2x squared. So this leaves us with 5x squared. Next we have minus 6x minus 6x, which is minus 12x, plus 3x gives us minus 9x. And finally we have a plus 9 that can just go on the end, and that's equal to 5. Since this is a quadratic, to solve it we need one side to be equal to 0. And so we can subtract 5 from the right hand side, which makes the right equal to 0. And we have to make sure that we do the same on the left. And so the left becomes 5x squared minus 9x, and 9 take away 5 is plus 4. Now, since we have a 5 in front of the x squared here, the easiest method to use is probably to use the quadratic formula and to substitute in our values of a, b and c. For this example, I'm going to factorise. So this becomes 5x minus 4 multiplied by x minus 1, and that's equal to 0. Now, since we have two brackets multiplying that make 0, we know that either the first bracket must be 0 or the second bracket must be 0. And so we can now solve these independently. So starting on the left, we can remove the minus 4 by adding 4 to both sides. And this gives us 5x is equal to 4. And we can now divide both sides by 5. And so we get x is equal to 4 over 5, or 4/5. Looking at the other equation, x minus 1 equals 0, we can solve this by simply adding 1 to both sides. And we get to x is equal to 1. So these two form the first part of our solution. We now need to find a corresponding value of y for each of these x values, and we can do this by taking our rearranged equation from earlier, y equals 2x minus 3, because y is a subject already, and substitute in our values of x. So starting with when x is equal to 4/5, this becomes y is equal to 2 times 4/5 minus 3, which gives us y is equal to minus 7/5, or minus 7 over 5. So these two make our first pair. We can now look at what happens when x is 1. So the equation becomes y equals 2 times 1 minus 3. 2 times 1 is 2, minus 3 is minus 1. So y equals minus 1, and these are our second pair. So our final solution to problem 2 is x is equal to 4/5, y is equal to minus 7/5, that's our first pair, and x is equal to 1, y is equal to minus 1, and that's our second pair. In problem 3, we're asked to find the coordinates of the points where the lines with equations x minus 2y minus 12 equals 0 and x squared plus y squared equals 8x plus 2y plus 3 meet. Now, when we're asked to find the coordinates of where two lines meet, what we need to do is solve their equations simultaneously and then write our solutions as coordinates. Now here, since we have a linear and a non-linear equation, to solve these we need to substitute one into the other, and the first thing we need to do is rewrite the linear equation with either x or y as a subject. So starting with x minus 2y minus 12 is equal to 0, we can make x a subject. And we can do this by removing the minus 2y, by adding 2y to the left, and doing the same on the right, and also removing the minus 12 by adding 12 to the left, and also adding 12 to the right. So on the left hand side, the minus 2y, the minus 12 and the plus 12 all cancel out to just leave us with x, and on the right, 0 plus 2y plus 12 just gives us 2y plus 12. And it's important that we know that x is equal to 2y plus 12 because we can now take this and substitute this into the nonlinear equation in place of x. So our nonlinear equation, x squared plus y squared is equal to 8x plus 2y plus 3 now becomes, in brackets, 2y plus 12 squared plus y squared is equal to 8 times x, which is now 8 times 2y plus 12 plus 2y plus 3. We now have an equation that just has y's in, so we can expand, simplify, rearrange, and solve. So starting with the first bracket, we can rewrite this as 2y plus 12 multiplied by itself, so multiplied by 2y plus 12 plus y squared is equal to, we can expand the bracket on the right, so 8 times 2y is 16y, 8 times 12 is plus 96, and we still have a plus 2y and a plus 3 on the end. We can now expand the bracket on the left hand side, so we have 2y multiplied by 2y, which is 4y squared, 2y multiplied by 12, which is plus 24y, 12 multiplied by 2y, which is again plus 24y, and 12 multiplied by 12, which is plus 144. We still have a plus y squared on that side, and that's equal to, and we can simplify the right hand side slightly by collecting together the 16y and the plus 2y, which give us 18y, and the plus 96 and the plus 3, which give us plus 99. We can continue simplifying on the left hand side by collecting some like terms there. So we have a 4y squared plus y squared, which gives us 5y squared. We have a plus 24y and a plus 24y, which gives us a plus 48y, and we still have a plus 144 on that side. And that's equal to 18y plus 99. Now, since this is a quadratic, to solve it, we need to make one side equal to 0. So I'm going to make the right-hand side equal to 0 by subtracting 18y and by subtracting 99. And I need to make sure that I do the same on the left. So we're going to subtract 18y and also subtract 99. So on the left, we have 5y squared plus 48y minus 18y is 30y. Plus 144 minus 99 is 45, and on the right we have 0 because everything cancels out. Now looking at this equation, we can actually divide every term by 5, and this is going to give us a y squared at the start, which often makes things a little bit easier. So dividing everything by 5, this gives us 5y squared divided by 5 is y squared, 30y divided by 5 is 6y, and 45 divided by 5 is 9, and that's equal to 0. And now we can try and factorize. So we're going to look for two numbers that multiply to make 9 and add to make 6. And those two numbers are 3 and 3, because 3 times 3 is 9 and 3 plus 3 is 6. So we can write out our two brackets. They're going to have a y at the start of each because y times y is y squared, and our two numbers 3 and 3 just go at the end. So we have y plus 3, and that's still equal to 0. Now here we have a bracket multiplied by another bracket to make 0, and this means either the first bracket, y plus 3, is equal to 0, or the second bracket, y plus 3 is equal to 0, but since this is the same bracket, we're just going to get one solution here. So if y plus 3 is equal to 0, we can subtract 3 from both sides, and we get y is equal to minus 3, and this is the first part of our solution. To find the corresponding value of x, we're going to take our rearranged equation from earlier, x is equal to 2y plus 12, because x is already the subject, and we're going to substitute in here y equals minus 3. So when y is equal to minus 3, this becomes x is equal to 2 times minus 3 plus 12. And since 2 times minus 3 is minus 6, plus 12 gives us x is equal to 6. So these two form our solution. Now we're asked to find where these two lines meet, and we can see from our solution that they actually only meet at one point, and it's the point that has x coordinate 6 and y coordinate minus 3. So our final solution to problem 3 is the point 6 minus 3.